All right, so we're solving square roots and other radical equations today. A radical equation is an equation that has a variable and a radicand, or a variable with a rational exponent. If the radicand has an index of 2, then it's a square root equation. How we're going to solve these radical equations? Well, we're going to isolate the radical on one side of the equation. We're going to raise each side to the power suggested by the index. So if it's a square root, we're going to square both sides. If it's a cube root, we're going to cube both sides. We're going to do whatever we have to do to clear off that radical. So take a look at problem 1. Solving a square root equation. The square root of 4x plus 1 minus 5 equals 0. So the first thing we want to do is we want to isolate the radical. So we want to get rid of everything on in this case, the left side that's outside the radical. So what has to go away? How are we going to get rid of the 5? So we will add 5 to both sides is correct. We need to raise both sides to a power to get rid of the radical. So what power should both sides be raised to? Correct. Because it's a square root, which is an index of 2, we're going to square both sides. And if we square a square root, well, we simply get the radicand of 4x plus 1. 5 squared, of course, is 25. And now we're simply going to solve the equation that we have without a radical. So it's a nice little linear equation. You guys should be able to solve this, and if you can't, you shouldn't be in Algebra 2. And we figure out that x equals 6. Questions on my first example? Okay. So then I've seen most of you guys with this. So as you look at B, and you guys did a nice job on this, so again, we'll take away the 6. Square root of x plus 4 equals 1. Square both sides. And you do, in fact, get x equals negative 3. Okay. Questions on solving a square root equation? Okay. Next, let's solve equations that have rational exponents. To solve equations of the form x to the m over n equals k, we want to raise each side of the equation to the power n over m, the reciprocal. Because if you remember from Algebra 1, that if you had x to the third to the fifth, what would that be? Simplify this expression. Correct. Recall that when you have power of a power, you multiply the powers together. And in order for us to get rid of the exponent, we need to change it to a power of 1, because then you don't have to show the power. So what do you multiply together to get a product of 1? Give me two numbers whose product is 1. So that's why when we get to 6x plus 9 to the 1/3 minus 5 equals negative 2. Again, the first thing we have to do is we have to isolate the term with the power. So what has to go away? What has to come off the left side because it's not to the 1/3 power? How are we going to get rid of the -5? To get rid of the power, we have to raise both sides to the reciprocal power. So what's the reciprocal of 1/3?
3.
But if we do that to the left side, we have to do it to the right side as well.
27.
So the right side does become 27. The left side becomes just 6x plus 9. Because 1/3 times 3 is 1, so it's 6x plus 9 to the first, which is simply 6x plus 9. From here then, we simply solve the equation, resulting equation. So since I'm about to run out of space, what's the answer for x? 3. Is everybody okay if I don't show that? How to get from 6x plus 9 equals 27 to 3? Take a look at B. Again, we have to clear everything out that's not being taken to the 2/3 power.
Which one would you do first?
On B,
Yeah, would you take the 2?
we have to get rid of everything that's not being taken to the 2/3 power. So what's not being taken to the 2/3 power? And how do we get rid of that too?
Divide it.
Yes. Remember that a number outside parentheses means it's multiplied, so we're going to divide both sides by 2. X plus 3 to the 2/3 power equals 4. We need to raise both sides to a power that will cancel out 2/3.
3 over 2.
That leaves this side as x plus 3.
6.
How'd you get 6? Okay, but remember,
4 and 3 and then divide by 2.
okay, that would be great if it was 4 times 3/2, but this is not times, this is 4 raised to the 3/2 power.
I don't know.
Okay? So we're going to do like we did yesterday. Remember yesterday? We'd rewrite 4 to the 3/2 as 4 to the 1/2 cubed. From yesterday's work, who can rewrite 4 to the 1/2 as a radical? Hassmeyer. It is the square root of 4. Square root of 4 is what, guys? And then 2 cubed becomes nice. So x, in fact, would equal 5. Now, when we're solving radical equations, where we're raising both sides to an even power, it's possible to introduce an extraneous solution. Extraneous solution is a solution to the equation obtained by raising both sides, but it's not a solution to the original. Because if we go back and look at our work, we know that x equals 5 is the answer right here, because that's the solution of x plus 3 equals 8. But just because it's a solution to this equation, it may not be a solution to the original. Because remember, it kind of goes off of this. Anybody with a calculator? What's 2 to the 6th power? I better not see you type it in 2 times 2 times 2 times 2 times 2 times 2 times 2. What's the opposite of 2 raised to the 6th power? Not negative. Because if you raise it to the 6th power, you'd have an even amount of negative signs, which would make it a positive. So any number raised to an even power is the same as its opposite raised to an even power. So when we raise both sides to an even power, we have to check to make sure our solutions aren't extraneous. A solution to the new equation that we get that may not be in an equation, a solution of the original. Therefore, it does become very important that we check all solutions back in the original equation. I don't know why I left myself such a gap there. Take a look at this example. What is the solution of each equation? Check your results. Square root of 5x minus 1 plus 3 equals x. Well, same thing applies. We still have to isolate the radical. So therefore, what has to go away? The 3. Tell you what, I'm going to move this to a new sheet. So someone tell me what this equation was again?
5
So again, the first step is we have to isolate the square root. To what power shall we raise to get rid of the radical? That leaves our left side as just 5x minus 1. Correct, George. Be cautious. Remember, when you square a binomial, it doesn't mean you simply square the first and square the last term. You have to FOIL. Because to square something means to multiply it by itself. So we have to FOIL x minus 3 times x minus 3. Let me know when you have an answer for that.
Teachers, at this time, we're going to ask again for junior picture retakes, A through L, to go to the balcony for the retakes. Also, senior portraits, M through Z, and junior pictures retakes, M through Z.
So who's got our FOIL? What you got?
I got x squared minus 6x plus 9.
X squared minus 6x plus 9. Everybody good with that? Again, be cautious. Just because you square a binomial doesn't simply mean you square the first and square the second. You have to FOIL. Common mistake students will make, they'll make that be x squared plus 9. And that is not the case. So now we're looking at solving this equation. Oh my word, what kind of equation is this that we should recognize from chapter 4? The what?
Quadratic.
Correct. And to solve a quadratic equation, we must make sure that it's equal to what? Good. So how are we going to make, which side are you going to make equal to 0, left or right? I would do the left myself. How are we going to make this left side become 0? And what are we going to do to move the 5x and the minus 1 to the right? Thank you. Use the appropriate colors here. Since I'm mixing red and blue together, we'll get purple. Oh my word, how do we solve a quadratic equation? What techniques do you remember from chapter 4? We could do the quadratic formula. We could factor.
10 and 1.
Okay? Definitely I like 10 and 1. What kind of signs do I need, Logan?
But, like, subtracting.
X minus 10 times x minus 1, because those factors have a product of 10 and a sum of negative 11. Therefore, ladies and gentlemen, what's our 2x's equal? Now again, since we raise both sides to the even power, we have to check to make sure that these are solutions of the original problem. And to do that, we just simply plug them in. So 5 times 10 minus 1 plus 3 equals 10. Ladies and gentlemen, evaluate the radicand. What is 5 times 10 minus 1?
49.
And what is the square root of 49?
7.
What is 7 plus 3?
7.
So is 10 a valid solution?
Yes.
Now let's evaluate 1. Did I get the right equation? Okay. Evaluate your Radicand, guys. Radicand's what's underneath the radical. Thank you. And the square root of 4? And 2 plus 3? Is 1 a solution? No. You know it's not a solution because it did not check out in the original. So therefore the only solution to this equation is x equals 10. Questions? All right, take a look at our last example. That is the square root of 5x plus 14 equals x. And again, I'm going to put that on a new sheet for myself. A little simpler this time because there's nothing outside the radical. So what do we have to raise both sides to? 2 is correct because it's a square root. So when you square a square root, you simply get the radicand. A little simpler over here because there's no FOILing to be done. It's just a single monomial, so it's just x squared. What kind of equation is it? Very good, which means it has to be equal to?
Yeah.
Yep. So again, we're going to zero out the linear side, if you will. Probably the easiest technique to use is the factoring technique, except those don't multiply to 14.
X plus 7, x minus 5.
Great idea. Those don't multiply to 14 either. Thank you.
-7.
I like -7 and 2. Which means, what's our x's? Good. So again, since we raised both sides to an even power, we got to check. Bless you. Ladies and gentlemen, I need you to evaluate the left side. What is 5 times 7 plus 14? And the square root of 49? Therefore, is 7 a solution? Now let's check -2. Again, evaluate your left side for me, please. And what is the square root of 4? Does that equal -2? No. Therefore, x equals -2 is not a valid solution, so we'll Ghostbuster it. And everybody in here is going, what the heck's Ghostbuster, Mr. Easting? Oh,